So we're going to learn how to name amines. Starting from the most basic amine, we have an sp3 hybridized nitrogen. What the draw program doesn't do is actually include the lone pair of electrons typically, but they're there to fulfill the octet. So if I have a nitrogen with 3 hydrogens attached, the most basic name is just ammonia. Now as I start to add on carbons, the longest continuous chain is what we're looking for. And so I have 1 carbon, that's the longest continuous chain. So my name here is derived from a methane, that is my parent chain. And so what I need to do is replace the E at the end with amine. So I'm going to just call this methanamine. Similarly, if we start adding more carbons, the carbon chain is increased. So this is no longer a methane, it is an ethane. So this is an ethanamine. And over here we have a propanamine. So I'll write propanamine. But the difference here though, in the 2 carbon chain, I could have the amine here or here, and it doesn't matter to the name. It's always going to be the number 1 carbon that the amine is on. But for propanamine, it does matter. This carbon chain, 1, 2, 3 carbons, this is the number 1 carbon, and I could have the amine situated on the 2 carbon. So I have to indicate here for sure that I have it on the 1 carbon. I can also call this a propan 1 amine, like that. And if I can scroll across here, we'll see the example that I was talking about. So over here, the example, I've got a 1, 2, 3 carbon chain. In the 2 position now I have the amine. So this is still a propanamine, but the difference is the position that it's in. So in the 2 position is where I have the amine, and so I can also call this a propan 2 amine. Okay, continuing with the naming of the amines, I've got a couple of examples here where I use a longer carbon chain, and we can see the positioning of the amine is important for the numbering. So we have an octane here, 1, 2, 3, 4, 5, 6, 7, 8 carbons. And in the 1 position over here, it's the highest priority is the amine. So I have an octan 1 amine. And then now in the next compound, in the 1, 2 position here, I've got the 2 position contains the amino. So this is an octan 2 amine. And so on and so forth as I start to move over. Sorry about all this. As I move over then in the 3 position here, is the amine. So this is an octan 3 amine, and then 1, 2, 3, 4 in on this one. This is an octan 4 amine. I'll erase that one there. So this is just to further clarify the naming and the positioning and how it's important to define the number of where the amine actually is. So where amines start to get interesting is that you can have more than 1 carbon group attached to a nitrogen, and it starts to complicate the naming, or it seems. And really all we're trying to do is just indicate that something else is attached to the nitrogen. I'm going to give a different example to get it in perspective right now. So if we were to start with a, say a butane group here, 1, 2, 3, 4, 5, sorry, a pentane group. And if I put the NH2 on here, so the amine on here, we know that this is a 2-pentanamine. So it's in the 2 position, it's 1, 2, 3, 4, 5 carbons, and it's a 2-pentanamine. But let's say I put a methyl group here. So in the 3 position here, I have a methyl group. So I know that this is a 3-methyl, and then this is a pentan. And in the 2 position is the amine. Right, so we're able to define where the methyl group is, and it's on the number 3 carbon. But as we're going to see, the methyl group can actually be on the nitrogen. So instead of having a number associated here, we're going to say that it's situated on the nitrogen, and I'm going to show an example of that right now. So starting with the base chain name for this one, we have one carbon, so it's a methane. So this is a methanamine. So here, I'm going to have a base chain name with one carbon, so methanamine. This is now a side group that's hanging off the nitrogen. So in this case, I'm going to say methanamine again. But in the N position is a methyl group. So it's an N-methyl methanamine, indicating that it is situated on the nitrogen here. So normally, and if it was on a carbon, again, if we were to have it up here, 1, 2, 3 N, this would be on the 3 position of the carbon, and I would say a 3-methyl. If the methyl is hanging off the nitrogen, then I have to indicate that it's an N-methyl. And that's it. It looks complicated, but it actually isn't that complicated. So continuing with more methyl groups on the nitrogen, my base chain is only one carbon in length. Again, I have a methanamine. And in the N position and in the N position is a methyl. So I have an N dimethyl methanamine. So this takes care of the base chain name. The methane is the base chain name. And this takes care of the 2 side groups that are hanging off of this. If I were to draw a blob around this, this is the base chain name with the highest priority functional group. Hanging off the highest priority functional group are 2 methyl groups, and I indicate they're on the nitrogens. And so for the final one, I'm going to erase this here. The base chain name is 1, 2, 3 carbons in length, so it's a propane. So I'll just write that down here. We know that it's going to be a propanamine, and in the 1 position is where the propanamine will be. So I'm going to put propan 1 amine. And now on the nitrogen are some side groups. So I have 2 methyls. So on the nitrogen and on the nitrogen, I have 2 methyls. So it's an N-dimethyl propan 1 amine. And that finishes off this series. 2 more examples of naming amines. I have the base chain name here. The longest one, if we were to count it, would be 1, 2, 3 carbons. This only has 2 carbons. This only has 1. So we're starting with a propane. So I have a propanamine. And the propane, or the amine, is in the 1 position. So it's a 1 propanamine, but I prefer writing it in this position. So I'm going to redraw that. But now that I got the base chain name done, I have a methyl substituent hanging off the nitrogen, and now I have an ethyl substituent hanging off the nitrogen. So this would be an N-ethyl and an N-methyl, and I need to name them alphabetically. So I'm going to start off the naming by saying N-ethyl, N-methyl. Now I'll finish it off with the propan 1 amine. And so similarly, the compound here, I've got a 1 carbon chain, a 2 carbon chain, and a 3 carbon chain as well up here. So that's the longest chain. So again, I also have a propanamine. The difference is that this is in the 2 position. So it's 1, 2, 3. So in the 2 position, I have the amine. So the naming is essentially exactly the same. The only difference is where the amine is. So I'm going to give myself some space here and rename this compound. So this one is an N-ethyl, N-methyl, propan 2 amine. So we start to get into more complicated amine naming. I have an example here that has two amines on it. So the longest carbon chain, 1, 2, 3, 4, 5, 6, 7. I'm dealing with a heptane, and I have two amines. So if it was one amine, it would just be heptanamine. But now I have two, and I have to put in a diamine. So I'm going to then call it a heptane. Note that the E still remains here. 2,6-diamine. So in the 1, 2 position is an amine. In the 6 position is the other amine. There's two of them, so I call it a diamine. And because I'm starting not with a vowel here, I'm keeping the E on the heptane. If it was just one amine, remember I would just call this heptanamine, and I would have dropped the E would be gone there, but that's because I'm starting with a vowel. And now that I'm starting not with a vowel here, I'm going to end with a vowel here. For the next compound, all I've done now, similar thing, but I've added a methyl group onto the nitrogen. But note what happens here, because when we were doing a methyl group before on a nitrogen, we would say we have an N-methyl. But now I have to indicate which of the nitrogen it is. And if I start the numbering, I have to start from either this side or this side. And if it was two amines with nothing on them, they're considered equivalent. So I'd be able to say that either side I could have started from, 1, 2, 3, 4, 5, 6, 7. It's a heptane, it doesn't matter. I end up with a 2,6-diamine on the molecule. I still have a 2,6-diamine, but because of the methyl group here, I'm going to start the carbon numbering at this side. 1, 2, 3, 4, 5, 6, 7. And there's a reason for that. Because on the 2 carbon now, I want the lower number. On the 2 carbon is this methyl. So what I do is I put a little superscript here, 2, to indicate the nitrogen that contains it. So on the 2 nitrogen, so the N with the superscript 2, there is a methyl group. So let's try to combine that all together and get the name for this. I'll give myself some room here as I erase this. And so what I'm going to say then is that in the 2 position, there is a methyl group, and that this is still a heptane 2,6-diamine, like that. All right, so it does start to get a little bit complicated, but I'll show you now where this starts to help out. So I scroll over. Same molecule again, but the only difference is that I have put another methyl group on each of the nitrogens. So since it's symmetric, it really doesn't matter which side I start from again. This was not symmetric, so it did matter. This is symmetric. So I could start the numbering from this side, but for consistency with the previous molecule, I'm going to start numbering from the right side. So 1, 2, 3, 4, 5, 6, 7. In the 6 position and the 2 position, again, I have an amine. But the thing is, I got to now indicate on the 2 nitrogen there is a methyl, and on the 6 nitrogen there is a methyl. So normally I would say if it was just on a regular amine like this, if it was on the same nitrogen like this, I would say it's an N-dimethyl. But the methyl is on 2 different nitrogens in this case. So on the 2 nitrogen, there is a methyl, and on the 6 nitrogen, there is a methyl. And so it is 2 methyls, so it's a dimethyl heptane 2,6-diamine. So this is essentially what you have to start doing when the amine is the highest priority group and you have different alkyl groups on different amines. So we're going to try some examples where the amine is not the highest priority functional group. So in the molecule on the left here, we've got a 1, 2, 3, 4, 5 carbon chain. So this is a pentane. I have both an amine and an alcohol on it. If we look up the priority, the alcohol is higher priority. So this will get the name of the molecule, and this becomes a side chain. The side chain naming for the amine is called an amino. So if we're to name this now, I'm going to say that I have a pentane. The E gets switched to an al for alcohol. Also, I'm going to change the numbering because the highest priority carbon is the alcohol. So it's a 1, 2, 3, 4, 5. And so in the 1 position is the pentanol, and I can switch that over. But again, my preference is to embed it into the name like this. So a pentan 1-ol. And in the 5 position then is this amino group. So I have a 5-aminopentanol. And so we can see then that if we were to start to add substituents onto the nitrogen, they're not actually part of the carbon chain. They're on the nitrogen. So I have a 1, 2, 3, 4, 5 carbon. The alcohol is the highest priority group. This is the number 1 carbon. 1, 2, 3, 4, 5 again. I still have a pentan 1-ol as in the previous molecule. In the 5 position is an amino. So in the 5 position, I have an amino. But the difference is that I have to now indicate that I have these 2 methyl groups. So I'm going to now include those into this. So it's a 5 on the N is a methyl, on the N is a methyl. So this is a dimethyl amino. And so this is the group. It's an amino group. Like if it was just an NH2, this would be an amino group here hanging off. But I have to indicate on the nitrogen, and on the nitrogen are these methyl groups. There's the amino. So in the 5 position of the carbon chain, this is what I have attached. And I'll try to write it all out right now. So 5 N dimethyl amino. And then the pentan 1-ol. Like that.